Okay then guys, let's have a little look at this intro for the first order differential equations solving by Bernoulli's method or Bernoulli's equation. These are solving equations of this form here, dy dx plus p times y equals q times y to the power n. P and q here mentioned are both functions of x. So that's what we've got. Anything we see like this we can apply. This is Bernoulli's equation and we can solve it using this simple substitution here. What we do is we let z equal y to the power 1 minus n. N is the value that's in this position here. So let's have a look at, and then we get an equation which involves an integrating factor method differential equation in order to solve. Okay, so let's have a look at an example then. Take this simple example here. We can see it's in the correct form to be Bernoulli's equation. We can see the value of n corresponds to 3, doesn't it? So here we do the substitution then. Let z equal y to the 1 minus n, wasn't it, here? And n is the value of 3. So z is equal to y to the minus 2, and that's equal to 1 over y squared. So let's get dz dx then, so we can do the substitution. So differentiating, we see that dz dx is equal to, now y is a function of x, isn't it? So we use the function of a function rule, minus 2y to the minus 3, multiplied by the function differentiated, which is y dy dx. So we get that, and we can write that as minus 2 over y cubed if we wish, dy dx. And then we can rearrange it to get dy dx to make the substitution. So dy dx will equal then, move the minus over, and then move the y cubed up, over 2, move the 2 from times to divide, and I'm writing it down from right to left, and that's dz dx, isn't it? So substitution gives then. So here's our equation at the top here, dy dx, which we can replace by this. So minus y cubed over 2 dz dx plus 3xy is equal to x squared y cubed. Now let's get rid of there's a y cubed that we can divide by. So let's do that. Divide by y cubed first then, here, all the way through every term, gives, here we'll just get the minus a half dz dx. Here we'll have plus 3x, and the y cubed, one of the y's will cancel just to leave y squared. And here we'll have an x squared, won't we? Now, this minus half we want to get rid of, so let's times by minus 2 all the way through. So minus 2 times this will give 1 lot of dz dx, which is what we want. Next, minus 2 times 3 is minus 6x. Now the 1 over y squared, remember what that was? That was equal to our z value, so let's put that in there. Is equal to x squared. And this is the standard form for integrating factor. If you just look at this for a moment, this is p. So we got p there, and we can solve by the integrating factor method. Okay, that's what we then proceed to do. So that's a method for Bernoulli's equation. There's 10 questions, I think, on this section, or thereabouts. All the best with the questions then, guys, and hope you benefit and get something from it. And by all means, send me an email, any questions you've got related to the first order differential equations. Cheers then.